absolute value. Hopefully you learned about absolute value back in like algebra 1 or maybe before. Maybe you even talked about it in geometry. Typically, when learning about absolute value, there's two different ways that it's taught. The geometric point of it and then the algebraic. If you understand both, today's lesson will be even easier to grasp. So let's take a look at the geometric definition. It's the distance away from 0 on a number line. So for example, if I'm drawing a number line, what number is right smack dab in the middle? 0. So I'll put 0 in the middle. And now what if I was to ask you, what is the absolute value of -4? If you're using the geometric definition, you would want to draw the numbers like -1, -2, -3, -4. And you would be counting how many units exist from 0 to -4. So that would be 1, 2, 3, 4. So how many units is -4 away from 0 on a number line? 4. And so our answer is the absolute value of -4 is equal to 4. That's the actual definition of absolute value. After you understood that well, we could just transfer, and probably your algebra teacher told you, hey, do you notice that if it's a negative number inside of the absolute value, you're just going to make the result positive? That's usually how we start to get accustomed to it. So let's go ahead and answer the algebraic way. What is the absolute value of 2? 2. What's the absolute value of -3? 3. Now, understanding both pieces can help you in solving for x. So if I'm solving for x and x is inside the absolute value, I have to think to myself, what numbers are 0 or are 3 units, sorry, 3. What numbers are 3 units away from 0 on a number line? What would your answer be? -3 and +3. So you have to think in two directions. -3 is 3 units away from 0 on a number line and +3. And that's the key idea when you're solving absolute value equations. Whatever is inside the absolute value could take on a positive value or a negative value due to the distance away from 0. So here's kind of the key steps in solving absolute value equations. Number 1, make sure the absolute value is by itself. Only the absolute value is what represents distance. Then you'll set whatever is inside equal to the number and the opposite of the number that's on the outside. Don't change the x's or anything within the absolute value. So let's go ahead and take a look at number 1. Number 1, the absolute value is already by itself. So to solve for x, I would set up the two situations. X could equal 4, or what else could x equal? -4. And so those are our answers. X equals 4, x equals -4. Number 2, if you're thinking about, I know I've been talking a lot about math of what undoes something. For example, I talk about equation. I'll say, what undoes addition? What would you guys say? Subtraction. What undoes multiplication? What undoes a square? Square root. What undoes a cube? Cubed root, right? We talk a lot about undoing. Here's what I'd really like for you to hopefully grasp by the end of today. What undoes an absolute value? 2 equations. Or you're going to see with inequalities, 2 inequalities. Because absolute value is distance away from 0. And there's 2 distances, the positive direction and the negative direction. So try to think to yourself, whenever I see absolute value, the only way I can undo it or get rid of it is to set up 2 equations. What would these equations be here? We would have x minus 2 could equal 4. Or x minus 2 could equal what? -4. Notice how I didn't change x minus 2. It's just the number on the outside. Then I solve for both of them. So I would add 2, giving me x could equal 6, add 2, and x could equal -2. Now, I don't have to check it, but I could. What would I do if I checked it? Where would I plug it in? Up here, the black print. If I'm asking what's the absolute value of 6 minus 2, the absolute value of 4 is 4. And if I ask what's the absolute value of -2 minus 2, The absolute value of -4 is 4. So I know that I got it right. X should equal -2 and X should equal 6. Number 3, there's a preliminary step we have to do before we can undo the absolute value. What do we have to do in number 3? Add 3, good. Isolate the absolute value, get it by itself. So we'll add 3, which will give us the absolute value of 8 minus 3t is equal to +1. Now think to yourself what you would do to undo the absolute value. After you know, I'm going to ask you to turn to your partner and the person with the darker colored shirt or jacket. If you could turn and share what you would do to go about solving this, turn to your partner.
I would. Oh no, that's just absolute value. That's a one. Oh yeah. So like 18. So.
Yes, I think I had one. Sorry. Oh, that's right. I have one in here. All right, guys, you should have said, the darker colored shirt should have said 8 minus 3t is equal to 1, and 8 minus 3t is equal to -1. That's how you undo the absolute value. Set it up equal to the positive answer and the negative answer. Then solve for both. So if you solved this, you would have -3t equals -7. What happens when you divide a negative by a negative? Makes a positive. Good. So we have 7/3, should be one answer. And then when we subtract 8 for the other equation, we get -9. Again, you're going to divide a negative by a negative. What should that produce? Positive. So t should equal 3 and t should equal 7/3. Any questions on absolute value equations? Okay, the last and final thing we look at is absolute value inequalities. If you're thinking about the math word inequalities, you want to be thinking about those symbols, those less than or greater than symbols. And to understand how to solve these, again, we need to think about the graph component first. So this question says, graph all the solutions for the absolute value of x is greater than or equal to 3. Don't do it yet. Listen to my words here. You need to shade all the values of x who are greater than or bigger than or equal to 3 units away from 0 on a number line. That was a lot. Let me say it again. You have to shade all the values for x that are bigger than or equal to 3 units away from 0 on a number line. Jay, a lot of people are looking at your screen. Do you know the answer? Okay, let's try it. Okay, so go ahead and shade this in. You do want to include 0. And let's see what you guys shade. I'm just going to do a walk around. I want to see how we think about it. Shade all the values that are bigger than or equal to 3 units away from 0 on a number line. Okay, guys, here is some of the things I'm thinking. And of course, I didn't get a chance to walk to everyone, but I'm seeing some people have the number 3. They have the number 4 shaded, and they have everything shaded this way after 3. And that's good because everything this way will be bigger than or equal to 3. But then I'm seeing some people think about it even kind of at a deeper level. Like Ava, what else did you have shaded? And you had it this way? Nice. Let's think about why Ava's way actually does work here. If I look at -4, Ava's saying -4 should be a solution. So if I plug -4 in for x, what's the absolute value of -4? 4. Is that bigger than or equal to 3? Yes. So Ava's solution, and others of you might have had it, is the correct one. It's everything this way and everything that way. Now, to help us understand these answers even better, I'm going to ask you to write your answer in inequality notation. So go ahead and write in inequality notation. That's not interval notation. So I'm actually not looking for the parentheses and the brackets here. So how do we write these answers in inequality notation? It would be all of the x that are greater than or equal to 3, or all of the x that are less than. In fact, I'm going to draw this in a different color. You'll see why. All of the x that are less than or equal to -3. This would be your answer. Tamika. How to write the answers? Oh, to graph the solutions that meet this condition. And so Ava graphed these, but now I'm asking what would the answer be in inequality notation? And we would say this: all the values of x have to be bigger than or equal to 3, or all the values of x have to be less than or equal to -3. Okay. All right, now let's do the same thing that we did for the previous one. Graph all the solutions that fit the absolute value of x have to be less than or equal to 3. If you're thinking geometrically, you would have to shade all the numbers that are smaller than or equal to 3 units away from 0 on a number line. Shade all the numbers that are smaller than or equal to 3 units away from 0 on a number line. You could imagine yourself being placed on the number line on 0 and think what numbers would be less than 3 units or less than or equal to. Okay, go ahead, shade it. I'm gonna walk around, see what you guys think. All right, guys, I'm seeing good things. Joe M, can you tell me what you had?
So I had the number line
Good,
with the numbers up to 5 on each side.
okay,
I went +3 with a closed circle, -3 with a closed circle.
nice. And he had everything in between. If you're thinking about why his numbers fit, any of the numbers that are shaded would make this inequality true. Example, if I tried to choose like -2, if I plug that in for the inequality, the absolute value of -2 would give me what? 2. Is 2 less than or equal to 3? Yeah, so we know it works. Now let's write the answers in inequality notation again, and I want you to see some consistencies, some things that are consistent for both situations. So go ahead and write in answers in inequality. That's what those less than, greater than symbols. Notation would look like this. All values of x that are less than or equal to 3, notice they're shaded this way, and all values of x that are greater than or equal to the opposite of 3. Okay, notice how the first example is an or situation. We learned about those yesterday or Tuesday. And the second situation is an and. They have to be joined in the middle. Notice what else is consistent. If I'm looking at this first piece, notice how the answers match that inequality without the absolute value on the right. If I look at the second situation, notice how those answers match that exact inequality without the absolute value. Now, take a look at either both of them or one at a time. What do you notice about the inequality on the other side? What do you notice about the answer to the inequality on the other side? I've tried to put them in different colors for you to hopefully see something that's common. Lydia? The exact inverse. I love that. This one is x is greater than or equal to 3. And then the other answer for the inequality switches the sign and switches the sign of the number. Same with the next one. This is a less than symbol. And the other answer for the inequality is going to have a greater than and a negative. Awesome. Remember, to undo an absolute value, you need two situations. If you have an inequality, you're going to either have a compound inequality that involves or a compound inequality that involves and. Here's the way to know if it's going to be an or versus an and. Now that we've done some warm up, let's go ahead and read the rule together. And it just cut out on me. There we go. Absolute value inequalities can be rewritten using the following properties. Here's the hint that I use that helps me. If it's a greater than symbol, I know it's going to be an or compound inequality. If it's a less than symbol, I know it's going to be an and compound inequality. So you can see when x is a greater than value, you're going to use or, less than is and. So take a look at this situation here. If I'm solving for x, this piece here would be a greater than symbol. I just misspelled the word greater to help me remember this is going to be an or compound inequality. If it's a less than symbol, I add the word or the letter D to the end to help me remember it's going to be an and situation. Other than that, in solving, you're going to copy what you see without the absolute value. So you can see that's consistent, or sorry, that would be over here. You can see that that's consistent for the top inequality and for the bottom inequality. The other inequality, you're going to use what Lydia said, the inverse. A less than symbol and a negative, a greater than symbol and a negative. Okay, this is going to be the type of situation where after we practice a lot of examples, hopefully this will feel very easy of how to solve. So go ahead and on the top of the next page, write that memory word, greater or less than. Also, if you have some distractions that are keeping you from paying attention here, I would ask that you put them away. The last thing that we're learning today, I'd really love for you to answer or to ask questions if you have them, so that you're not leaving here confused. So let's take a look at number one. Number one, in order to undo the absolute value, I need two inequalities. It's either going to be an or it's going to be an and. To determine what it is, I have to look at the symbol. Is this a greater than symbol or a less than symbol? Greater. So what word should I put in between? Or, good. Then I'll copy exactly what I see without the absolute value. So I know that x minus 2 has to be bigger than 4. Or on the other side, I'm going to copy the exact values, but I'm going to flip the sign, make it a less than symbol and make that number negative. I've heard some students like to think of it as when you divide by a negative, you have to flip the sign. That's great. Flip the sign and make this one negative. Now we solve for both of them and then write our answers in interval notation. So how do I get x by itself? Add 2. And I see that the values of x have to be less than -2, or add 2, or they have to be bigger than 6. So I graph these values on a number line. Should I have an open circle at -2 or a closed circle? Open, should I shade to the left of -2 or to the right? The left, good. So x has to be less than -2, or, and now I write the number 6 and 7. Should I have an open circle at 6 or a closed circle? Open, should I shade to the right or to the left? Right. To write my answers in interval notation, what's the smallest value x could be? -infinity, where do they go up to? Oh, it stops somewhere. -2, would I put a parentheses or a bracket there? Parentheses, and then the union symbol joins another set. 6, good, with parentheses to infinity. And that would be our answer. Okay, the next one is the exact same thing with the exception of the symbol. What type of symbol is this one? Less than. So what word should I have joining my inequalities? And, good. And then keep the same steps. Copy the exact inequality that you see without the absolute value. I always put it on the right because that matches where it goes on the number line. Then on the left, copy what you have without the absolute value, but don't write the symbol there. What do you have to do with the inequality symbol? Flip it, and what do you have to do with the sign of the number? Make it negative, yeah, take the inverse. And then solve for both. So we would add 2, and we have x has to be greater than or equal to -2, and add 2, x has to be less than or equal to 6. This is an and situation, so the values of x have to meet both conditions. So I'll draw a number line. Am I going to have a closed circle at -2 or an open circle? Closed. Am I going to be shading to the right of -2 or the left? It's a pointing in the direction to the right. And where do I stop? 6. Should I have a closed circle or an open circle? Closed. Turn to your partner. This time the person with the lighter color shirt in the group. You tell them what the answer would be in inequality notation. Or interval notation, sorry, interval. All right, guys, take a look. You should have bracket -2, 6 bracket. All right, let's do it again. On to the next one. What do you think we're going to have to do before we actually undo the absolute value symbols? Divide by 3. Get it along. Awesome. So we're going to divide by 3, divide by 3. And I would have the absolute value of x plus 1, that cancels, is greater than 2. Now, I know that there's an absolute value involved, so the only way to undo that is to set up 2 situations, 2 directions away from 0 on a number line. I know that I'm going to copy exactly what I see. X plus 1 has to be greater than 2. I'm going to copy what I see, but not write the sign, because what do I have to do with that inequality symbol? Flip it, and what do I have to do with the value of the number? Yep, inverse, make it negative. The last thing I have to do is know, is this going to be an or situation or an and situation? What do you guys think? Or, good, because it's a great or symbol. So I'm going to have the word or in the middle. And now I solve for x on both. So I'll subtract 1, and I get x has to be less than -3, or subtract 1, X has to be greater than 1. So now I draw my answers, and I'm going to have like -3 to the left. Should I have an open circle at -3 or a closed circle? Open. Should I shade to the left or to the right? Left. Good. At 1, it should be open again, and we should shade to the right. So in inequality notation, we would have -infinity to -3 with a what symbol? Parentheses. Good. Union with 1 to infinity. Should I have parentheses or a bracket around 1? Parentheses. Good. To infinity. Margot.
Okay, so for,
Yes.
last one we put, instead of three different parentheses, we had, oh, you did have a -3, -2, 6.
This one was an or situation.
Oh, sorry.
That one was an
Teachers,
and.
please excuse this interruption. We have about 20 minutes left in class, and if you have yet to have your students take the survey link that I sent through yesterday, the inclusion survey, I would ask that you please carve out about 5-10 minutes in the remainder of class to allow students to take that survey. Thank you. Bye.
All right, guys, we'll do 2 more examples, and I'll have you do the survey. Huh?
For number 2, like, why did you write it? Like, number 11.
I didn't write it like that because it was an and situation, which means the numbers have to meet in the middle. They have to make both inequalities true. So I couldn't say like the number 7 because the number 7 doesn't make both of those true. It's not bigger than or equal to -2 and less than or equal to 6. It is bigger than or equal to -2, but because it doesn't meet the other condition as well, it's not a solution.
Even like positive.
No, because
Oh, right.
-infinity, yeah, wouldn't meet the other condition.
Okay.
Good. All right, let's take a look at the next one. The next one is the absolute value by itself. Yes, so let's go ahead and set up our 2 situations. 2/3 t plus 1/2 has to be less than or equal to 1/6. And then copy exactly what you see again, 2/3 t plus 1/2. But what do you have to do with the symbol? Flip it, and what do you have to do with the number? Make it negative. Good, of 1/6. Ew, there's a lot of fractions. What could, oh, wait, I do need to know if it's going to be an and versus an or situation. What would it be? I don't know what symbol it is. My OneNote cut out on me. It's a less than. Good, so it's going to be an and. Less than. So I'm going to have an and situation. And what can I do to get rid of all of those fractions? Multiply by the least common denominator. Awesome. So I'll distribute a 6. When I distribute 6, how many times does 3 go into 6 evenly? Twice. So I have 2 times 2 times t plus, what is 6 times 1/2? 3. Good. Is greater than or equal to, here the 6's cancel, so we get -1. Now this is so much easier to solve. So I have 4t plus 3 has to be greater than -1. And then I'll subtract 3 from both sides, giving me 4t is greater than -4. Divide both sides by 4. And I get t has to be greater than -1. And go ahead and solve this next one on your own. Raise your hand if you have questions. All right, guys, go and take a look. You should have that t has to be greater than -1 and less than or equal to -1/2. Or sorry, greater than or equal to -1. I lost that equal bar. And less than or equal to -1/2. Any questions on this? Okay. The last two are more critical thinking questions. And I do want to make sure you guys have time to do the survey. So if you want to see those online, they are filled out online, but we're going to go ahead and stop there.